Hey everyone, this is the Math Nexus, and we are continuing the exercise 1.5 of O-Level and IGCSE admits in this lecture. And again, this lecture is going to concentrate upon modulus graphs. And if you see, we are going to solve from question 2 onwards. And if you see right now, it's written question 2a, complete the table of the values y is equal to x minus 2 in a modulus plus 3. And the thing is that this question is simple. We do not need any hard and fast rule to solve this. We just have to input the x values given in the question and find out the y values and just input it into the table itself. So question 2a. And the thing is, we are just going to copy the equation y is equal to x minus 2 and a modulus plus 3. And what it's going to give is, now when x is equal to minus 2, we have y is equal to minus 2, minus 2 minus 2 plus 3, which will give us y is equal to minus 4 in our modulus will become positive 4. And positive 4 plus 3 is 6, 7. 7 is y is equal to 7 for the first value. And then when x is equal to negative 1, we already have the answer. When x equals to negative 1, we have y is equal to 6. And when x equals to 0, we are going to say y is equal to minus 2 in a modulus. 0 minus 2 is minus 2. So minus 2 in a modulus is equal to positive 2. Positive 2 plus 3 is 5. So in fact, positive 2 plus 3 is equal to 5. And so we are going to write 5 here. We are going to write 7 here. And when x is equal to 2, x is equal to 2, we have y is equal to 2 minus 2 is equal to 0. So it's not going to be anything plus 3 only. And we have to mind my line. It's really bad, I know, but bear with me. When x is equal to positive 3, we have y is equal to 3 minus 2 plus 3. And 3 minus 2 is equal to 1. Okay, so 1 plus 3 is 4. Y is equal to 4. So it's equal to 4. Okay. And the last value we have when x is equal to 4, y is equal to 4 minus 2 plus 3. 4 minus 2 is 2. So y is equal to 5 again. So again, it's going to be 5 here. And that's for part A. It's just that simple. Just fill in the values for the x values we have been given. Then part B is much more complex than this, which tells us to draw a graph. Okay, before we proceed on to drawing a graph, we have to concentrate on the main components that allow us to draw a graph, which is, as we discussed in the previous lecture, the shape of the graph, the y-intercept, the gradient, and the vertex. The thing is, however, we have been given the values, okay, for which x is greater than equals to negative 2 and lesser than equals to 4. So that means that we do not have to consider these things right now. Okay? We do not consider right now. They are not applicable, you can say right now, because we already have been given the x values and we can just directly plot the graph through these coordinates. We just have to input these coordinates in the graph and that's it. Okay, so again, and this is not complex. Okay, we do have our graph set for now, and what we are going to do is just copy. In fact, what I'm going to do is take a screenshot here, this of this, and this, so that it's going to be easier for my values. Depending on a different layer. And this is our first point. The second point is when x is equal to negative 1, y is equal to 6. Here it is. When x is equal to 0, y is equal to 5. So here's the third point. And when x equals to 1, y is equal to 4. X equals to 1, y is equal to 4. And when x equals to 2, y is equal to 3. X equals to y is equal to 3. And similarly, when x is equal to 3, y is equal to 4. Again, it's going to be reflected here. And this shows that this is a modulus graph. And another thing that it shows is, let me complete the graph first, x equals to 4 and 5. Okay. And another thing that it shows is, it's not important that the graph or the vertex is at the point where the y value is 0. It's not at this point. Okay. And that's an important thing to note. It can be any, the reflection can be anywhere at any y-axis value. However, if it is a graph, a modulus graph, it cannot be, and it's mostly not a negative y value. Okay. We do not take a negative y value. It's just reflected back from that. It's mostly that case. Let me make a line for this. From here, we are going to connect all these points up here and up till here. And that's our graph for for question number 2 itself. Okay, let's proceed to question number 3. Okay, so for question number 3a, y is equals to x plus 1 in a modulus. So before I just start solving this question, I need to emphasize the fact that whenever you read any question, whether it's in a practice or in an exam, you underline the important points of the question itself, and that allows you to concentrate on what is asked more specifically. So That's an example. So y is equals to modulus of x plus 1. Okay, and this is basically a simple equation. So we have two equations before we start to compare this. First of all, we do know that still now what we have done in a modulus comprises of straight lines, and modulus functions. Okay, we do know these two things. Okay, the thing is that what is the equation for modulus function? It is y is equals to a and fx in a modulus plus c. Okay, and the second equation is y is equals to mx plus c. This is the equation of a straight line. Okay, now before we start, we need to know the shape of the graph, the y-intercept of the graph, the vertex of the graph, and the gradient of the graph. These are the most basic things we need to know, and I've discussed these in the previous lectures. Exercise 1.5 question 1, I discussed it in detail. And what we are going to do is simply just compare it. So y is equals to modulus of x plus 1. Okay, we just concentrate right now. Let's find the shape, and if we compare it, the modulus has a positive value, which means a itself, if you compare it, is positive. So our shape will be v type shape. Okay, then is our y-intercept, and when does the y-intercept come? Is when x is equals to 0. So when x equals to 0, y is equals to 0 plus 1, which is 1. Okay, then we have to find the vertex. I am doing this fastly because I've explained this a lot in question number 1. So no need to, and if you don't understand right now, go to exercise 1.5 question number 1, and it's explained really much in that question. Okay, so vertex. The x value of the vertex, again, we take the modulus of the function x, so x, and assign it equals to 0. So x equals to 0, and the y-intercept is the plus c, which is 1. Okay, and so y is equals to 1. So the vertex is at the point 0, 1. And if you just concentrate right now, the vertex is at the same point as the y-intercept. When x equals to 0, y is equals to 1. Okay, so another thing, and the last thing, we have the shape of the graph, we have the vertex, and we have the y-intercept, which is 0 and 1, while the shape of the graph is a V shape. Now, the thing that is left is the gradient. Now, if we just compare y is equals to modulus of x plus 1 with y is equals to mx plus c, okay, we do know the gradient is with the x coordinate itself. So right now, with the x coordinate, there is not any value given, so we assume that value to be 1 itself. So our gradient is 1, and without any denominator, there is a imaginary 1. So again, what's the formula of the gradient? Rise upon run. And I've explained in the previous lecture, but let me explain it again. The rise is the changing y values in a graph, and the run is the changing x values in a graph. Okay. Now, that's all we need. This is the information we need to draw the graph. We just go on. We just copy 0, 1. Now, we have 0, 1. We have the gradient, which is 1. And that's all we need. 1 upon 1 degree. Rise upon run. Okay. Now, let's plot the points. Why the gradient is really helpful is I'll tell you right now. So x is equals to 0, y is equals to 1. So when x is equals to 0, y is equals to 1, we only have 1 point. And that's where the gradient is most important. Let me just plot it directly. Okay. And that's where the gradient is most important. And I want to clarify one fact. If most of you are confused in this thing, that why did I count the smaller boxes, not the bigger boxes, when comparing the rise upon run? Well, and if you are just watching this video for the first time, don't be confused from this. I'm just talking about the previous lecture. The thing is that I counted the smaller boxes, so no need to worry. You can also count the bigger boxes. I just counted the smaller boxes so that I could have more space to work on, and you can just count the bigger boxes, and the thing gradient works on ratios. So if you just use the bigger box for rise and the bigger box for a run, it's going to give you the same answer. It's going to be same ratio actually. So 1 is our rise and 1 is our run. So here it is. So 1 point here comes, 1 point, another point here it comes, another point here, rise and run here. And I think these are enough for right now. We do not know where this graph ends, and we do not have to find it out. It is not required in this question. So what we're going to do is just make a line on these coordinates, and that's it. But we all know that this is a modulus graph, so it's really important that we make its reflection. And this is a 90-degree. And what we'll do is use the gradient to give us another path, 1 rise, 1 run, so that we do have a path for our reflection. 1 rise, 1 run again, and that's enough for a path. And it's ending on 5. So we just go on to 5. Here's 5. Yes, it's passing 2 points. That's it. This is the graph for question number 3, part A. Let's go on part B. Here is this. Yes. Okay, so part B. What do we have in part B? We have y is equals to the modulus of x minus 3. Comparatively, it's kind of the same question, some difference. Okay, now what we're going to do is y is equals to mx plus c, so that we can compare it. Y is equals to, and this one I'm going to write is the modulus equal to a fx plus c. So simple. What we're going to do is first find out our, what we're going to find out first. We're going to find out our shape, which is again a v shape. Then what we're going to find out, we are going to find out our y-intercept, and the y-intercept is -3 because y is equal to mx plus c. -3 is the answer when x equals to 0. And let me prove this fact. When x is equals to 0, then we have the y-intercept. So what's going to happen? Y is equals to 0 minus 3, which is equals to -3. Yeah, method proved. We have the y-intercept, then what we have to find the vertex. And for the vertex, you have the formula. We take the function of x and assign it to be 0. And now what will be the y value? The y value will be this -3 according to the formula. We compare it with c. Y is equals to -3. Again, if you don't understand what I'm doing right now here, go to my previous lecture on question 1 and it's explained really easily there. So y is equals to -3. And that's our vertex. Then the gradient. The gradient is, what's the gradient? Y is equals to mx. What is with the x coordinate? There is nothing, which means there is a 1. So gradient, I forgot to write now. M is equals to 1 and upon 1, which is 1 is the rise, by 1 is the 1. Okay, that's it. Now we are going to draw the graph for these coordinates. And what do we have? 0 and -3. So we have 0, 0 and -3 is our vertex and the y-intercept. They are the same. And then what we, well, they are not the same, but in this case, they are the same. So we have the gradient to be 1 upon 1, and that's what we need. M is equals to 1 upon 1. Okay. What we are going to do right now is, when x equals to 0, y is equals to -3, goes all the way down here. And then what we're going to do is just give us a path. 1 rise, 1 run. There we go. 1 rise, 1 run. Here it is. 1 rise, 1 run. And that's enough for me. 1 rise, 1 run. 1 rise, 1 run. 1 rise. So that's it. We're going to make a line right now. From here it goes. That's the wrong point. From here it's going to go to here. And then from this point it's going to reflect to this point. And so on and on and on. We do not know it. From here it can go till here. We do not know, and our question does not require this. Okay. So this is for our part. What was the part? And this is part B of our question number 3. Let me do this. Okay, on to part C. Let me erase it. Okay, so for part C we have y is equals to 2 minus x. So that's it. What we have to find the shape of the graph. Let me put this x in a modulus. So the shape of the graph, if we see right now, let me explain this. We had two equations. Y is equals to a, the function of x in a modulus plus c, and the second is y is equals to mx plus c. And now if we just concentrate, we have 2 minus x. That means the value of a, which is being multiplied with x, the function of x itself, is a negative value. So our shape will be something like this. Okay, and then what we have is the y-intercept. So y-intercept is when x is equals to 0. So when x is equals to 0, y is equals to 2 minus 0, which is in return equals to 2. That's it. That's the y-intercept. And then we have to find the vertex. What's the vertex? The vertex is, if we take the function of x and assign the value to be 0, and when again 0 here, and again when, what's the plus c? Plus c, it's jumbled up, but if you see, it can be, this can also be written as y equals to negative x in a modulus plus 2. So we can say that this plus c is equals to plus 2. So y is equals to positive 2. That's our vertex points. And then the gradient, which is one of the most important things here, we have the gradient which is 1. Because with x there's nothing, so 1 is our gradient, 1 upon 1. 1 is the rise, upon 1 is the run. So that's a gradient. We have all the points. Just copy these points. Vertex is at, let me get it. Yes. Okay, freehand. Then we have one of our points, x equals to 0, y is equals to 2, and we have the gradient is 1 upon 1. Okay, there's two things we need right now. The vertex and the y-intercept is same in this case. However, we do know the shape is going to be something like this. I've discussed there are only two shapes for the modulus graph, this and this. This V shape is when we have the A value to be positive, and this A shape without the A stick is the negative value. Okay. So now if we just plot this graph, 0 and 2, x equals to 0, y equals to 2. We take it here. So one rise, one run. Okay, this is the point, first point, one rise, one run. This is the second point, and I think 2 points are enough. Same on this other side, one rise, one run, one rise, one run. And the reason why I'm drawing like this, why I'm not drawing upwards, like one rise, one run. How do I know which direction is correct? My friend, I told you before that that's why the shape is important. If we do know the shape, we know in which direction we are going to take the gradient. Okay, so we already know the shape is going to be something like this. So I'm taking the gradients to be downwards. Okay, that's why the shape helps us. So again, take the line, pass through these points, and I think I'm going to the negative side. Okay, that's our, and this is going to be our reflection. -3 years. And that's it. This is the graph for part C. Let me see. Yes, this is the graph for part C. Let me erase the board for part D. Okay, so for part D, we have y is equals to x minus 3 in a modulus plus 1. Okay. So what we are going to do next is, again, first of all, the shape of the graph we take is a positive. There's a positive value outside the modulus. So we are going to take the shape of the graph to be a V shape. Then we are going to take the y-intercept. Y-intercept comes when x is equals to 0. When x is equals to 0, y is equals to 0 minus 3 in a modulus plus 1. So y is equals to -3 in a modulus will become +3 itself. So +3 plus 1 is 4. Okay. So now we have to find the vertex. For the vertex, what we are going to do is, okay, we take the function of x in the modulus, take it out, and assign its value to be 0. So x equals to 3 at the time of the vertex. So what's the y value of the vertex? Just simply write down this c value plus 1, which is given in there. So y is equals to 1. So we have the vertex point, which is 3 and 1, and we have the y-intercept, which is 0 and 4. Now the gradient is going to be something like what's the gradient? With the x coordinate, we have nothing, which means we assume it to be 1. So 1 upon 1, 1 is the rise, while 1 is the. Okay. So we have these things. Let's copy this on the graph. We are going to copy 3, 1, and 0, 4. 3, 1, and 0, 4. Okay. Now just copy these coordinates. When x equals to 3, y is equals to 1. X equals to 3, y is equals to 1. 1 point is here. And x equals to 0, y is equals to 4. The other point is here. And what was the gradient? 1 upon 1. So 1 rise, 1 run. Here it goes. 1 rise, 1 run. Another, and here it is. And for the reflection, now this what is our vertex? If you see, our vertex is 3 and 1. So this is the point where the graph is going to reflect 3, 1. So from here, 1 rise, 1 run. Again, 1 rise, 1 run. And I think these two are enough to give us a path. In fact, let's make it again. That's enough. So what we're going to do is make a line, something from here, and just pass it through here and make its reflection, which means like that, from here to there, and the reflection goes here, from here till here, from here till here. Yes. So this is our graph for part D. Let's go to part E. Let me erase this board. Okay, for question number 3E, we have the question y is equals to modulus of 2x plus 6 minus 3. And I've discussed in the previous lectures that before we draw any graph, we just ignore the modulus. Okay, the modulus actually acts upon the graph after the first component is made. Okay, so the first we make this graph itself, then we go towards the reflection. That means first a straight line is made, then the modulus acts upon it and it's reflected. So that means first we ignore the modulus. Y is equals to 2x plus 6 minus 3. And y is equals to 2x plus 6 minus 3. 6 minus 3 is +3. Okay, so that's it. And then what we're going to find is the shape. Okay, now if we just consider here, y is equals to 8 function of x in a modulus. Let's see, we see that the modulus has a positive value. That means the shape is going to be a V shape. Then the y-intercept. The y-intercept is found when x is equals to 0. So when x is equals to 0, y is equals to y is equals to 2x plus 3. So y is equals to 2, 0, 0 plus 2. That's it. And for the vertex, however, we are going to take 2x plus 6 in the modulus. 2x plus 6, take it out of the modulus and assign the value to be 0. Then solve this. 2x is equals to negative 6, x is equals to negative 6 upon 2. Which 2 1 is 2, 2 3 is 6, x is equals to negative 3. Okay, that's the vertex x value. The y value is directly negative 3. Y is equals to negative 3. Let me counter check it again. Y is equals to, just input the value 2 minus 2 plus 6 minus 3. We do the 6 minus 6 plus 6, y is equals to negative 3. That's it. Okay, so we have the vertex, we have the y-intercept, and we have the shape. We do not have the gradient, however, we find gradient. See, with the x coordinate, we have the value 2. So our gradient is going to be 2 upon 1, which is 2 is the rise, and 1 is the run. We have the gradient, we have the y-intercept, which is at 0, 3. We have the vertex, which is at negative 3, negative 3. And we have, last but not the least, we have the shape of the graph, which is a V shape. And now let's plot the graph through this information. Yep. So freehand negative 3, negative 3, then 0, 3 is the y-intercept. Gradient is equals to 2 upon 1, and the shape is a V shape. Okay. Let's plot these coordinates first of all, negative 3, negative 3, and we go up till here. That's the first point. When x equals to 0, y is equals to 3. X equals to 0, y is equals to 3. So it's going from here till here, and if you just see the gradient, 2 rise, 1 run. 1 here, 2 rise, 1 run. Again, another one here, 2 rise, 1 run. Okay, this is correct. So this point is our vertex. Okay, so that means from this point, our graph is going to be reflected. And so what we're going to do is reflect it back here. 2 rise, 1 run. 2 rise, 1 run. These 2 points are enough to give us a direction. So till here we have the graph, and from this point it's going to reflect up till 3, passing through these 2 points. From here till here, and from this point till this point. And that's it. This is our graph for the last part of our question number 3 part E. That's it. I will meet you in the next lecture with the rest of the questions. This is a really lengthy exercise, and we will wind this up in the next lecture. Thank you.